Hello everyone. So welcome you to the YouTube channel of Infinity Learn by Sri Chaitanya. Okay. Now physics, motion of center of mass. Okay. So if you remember, in the last class I have covered what is center of mass and how to locate center of mass, right? Now today we are going to study what is the motion of center of mass, how does the center of mass moves, under what conditions, and what is the principle associated with it, right? So we will be covering those things. Okay, so let's start. Motion of center of mass and conservation of momentum, these are the two topics that I will be covering today in this particular lecture. Now velocity of center of mass, first thing. So as you can see here, just 1 minute. Okay, as you can see here, velocity of center of mass is what? D m1 d r1 by dt, like where it came from? Position of center of mass we all knew. What was it? It was m1 r1 plus m2 r2 up till mn rn. Do you remember this? Upon total mass. Now if you differentiate both sides, what will happen? It will get the form of this equation. Why? Because if you differentiate, it will become drcom by dt. Now what is this? This is velocity of center of mass, which will ultimately become like this: m1 dr1 by dt plus m2 dr2 by dt plus m3 dr3 by dt up till mn drn by dt, right? So what will happen? These will become this will become your velocity v1, that means velocity of the particle v1, this is the velocity of the particle 2, velocity of the particle 3, and so on. Now ultimately what are you getting? When you write the formula of velocity of center of mass, it will become this. It is ultimately m1 times v1 plus up till mn times vn upon total mass m. Do you understand this thing? Okay, so this is how we represent the velocity of center of mass: m1 v1 plus m2 v2 up till mn vn upon m. Now one thing you might understand here, it's a very small concept but still you can understand it here, that m1 v1 is actually the momentum of the first particle, m2 v2 is the momentum of the second particle. Likewise you can see that we are actually adding up momentums, vector p1 plus vector p2 plus vector p3 up till this. Can you see this? So actually in order to find the velocity of center of mass, we are adding all the momentums of all the particles vectorially and then dividing them by capital M. Are you understanding? So I can say it like this: net momentum of the system, or the total momentum of the system upon total mass of the system, will give you velocity of center of mass. I hope you are understanding this thing. Come and tell me, is it clear? Fantastic. So let's move ahead. So finally I can say that momentum of the system becomes equal to mass times velocity of the center of mass. Okay, momentum of the system is equal to mass times velocity of center of mass. Now from this particular statement, there are two things to be learned. Number one is how to find out the velocity of center of mass, number one. Okay, with this formula we can find it out. Second thing, how the momentum of the total system is associated with the velocity of center of mass. That means either what you can do is add momentum, individual momentums of all the particles to find out the total momentum of the system, or another thing that you can do is you can simply find out the velocity of center of mass and just multiply it with mass to get the momentum of the system. Now it's going to work two ways. This is helpful to find out VCOM, and once you know VCOM, it is very helpful to find out the overall momentum of the system. Are you understanding? So one thing that we can be 100% confident here is that velocity of center of mass is directly linked with the total momentum of the system, right? Yes or no? Yes. Okay. So velocity of center of mass is linked directly with the momentum of the system. Okay. Now it is very helpful. Later on I will tell you how. So finally I can say that velocity of center of mass is how much? This is m1 v1 plus m2 v2 up till mn vn upon total mass, right, upon total mass. Now if I differentiate this equation both the sides, okay, if I differentiate this equation both the sides, then what will happen? I will get this. Acceleration of center of mass, which will become m1 dv1 by dt plus up till mn dvn by dt upon total mass. Do you understand this? Simple. So I have differentiated this equation both the sides, and what I have got is acceleration of center of mass, which is this. Now if you look at this equation carefully, you will realize that this dv1 by dt, dv2 by dt, these things, what are they representing? They are representing actually the acceleration of the single particles, like this. This is what it is representing, the acceleration of the second particle. Yes or no? Right? Now one interesting fact is here, m1a1, m2a2, m3a3, what are they representing? They are actually representing the net force on the individual particles if you look closely, because when you study force, what is the net force? You will say, sir, force on the body, net force on the body is mass times acceleration, net acceleration of the body. Is it right or not? Yes or no? So net force on the body is mass times net acceleration of the body, right? So if I say m1a1, so what is m1a1? m1a1 means it is the net force on the first particle. m2a2 means it is the net force on the second particle. m3a3 is the net force on the third particle, and mnan is what? The net force on the nth particle. So this is how acceleration of center of mass is actually net force on particle 1 plus net force on particle 2 plus net force on particle 3 up till net force on particle n upon total mass. Okay? Okay students. Now let me explain you this thing a little bit further. Okay, less space is here, so I will utilize this, I will erase it and utilize it. Now let me explain what I was trying to say here. Okay, look here, when I say F net on any particle, it is mass of that particle times acceleration, net acceleration on the particle, right? So when I say m1a1, so it is m1a1 means this is the net force on particle number 1. Then comes, if I write m2a2, then it comes net force on particle number 2 and so on. Okay, so on. So if I add all these forces, exactly what I am getting, that we need to understand. See, when I talk about net force on first particle, now first particle, how many types of forces are there, or how many types of forces are possible on first particle of any one object of the system? You will say, sir, first particle will have, see, this is the first particle, particle number 1. It might be interacting with particle number 2, particle number 3, particle number 4, particle number 5 and particle number 6. Like this, it might be interacting with n particles, right? So it might be pulled or pushed by the second particle, by the third particle, by the fourth particle and up till by the nth particle. Can you see that? So what are these? these are the interaction forces of first particle with the remaining particles of the system, right. So technically what I am trying to do is, I want to examine what is this net force on the particle number 1. If I am talking about net force on particle number 1, that means I need to figure out what are the kind of forces that are acting on particle number 1, right. So first I need to figure out if there is particle number 1 I am talking about, so how many kind of forces might be acting on this. So first I can say the force by the second, third, fourth, fifth and all the n minus 1 remaining particles. These are all the interactive forces with the particles of the system, and I can call them as internal forces. What I can call them as? I can call them as all these forces, they come under the category of internal force of system, or I should say interactive or interaction forces. Okay. So first variety is this, internal forces or interaction forces are there. Another thing is that outside of this n particle system there might be some other force like gravitational force, there might be some other force which is coming from externals, which is coming from outside. So I can say on particle number 1, the forces due to interaction of other particles, the forces due to interaction of other particles plus any external force is there. This is the net force on particle number 1. Do you understand this, students? Okay. So when I am talking about particle number 1, this is the net force acting on the particle number 1. Due to 2, 3, 4 other n minus particles, this is the net force acting. Right. Now what I am trying to do is, I am trying to figure out okay, what I am trying to do is, I am trying to figure out here that if acceleration of center of mass is given by m1 a1 up till mn an upon total mass m, then what does it actually means? Okay, let's try to understand. See, now what is happening, m1 a1 is what? Net internal force or interactive force, total interaction plus external. Likewise, this is true for all the particles. This is true for nth particle also, for the first particle and for the nth particle. Likewise, we will add, right, for the first particle, then for the second particle, then for the third, and then finally for the nth particle we will do it like this. Okay, students. Now let us understand what is the meaning. So I can just what is the meaning of this? Total interaction force I am talking. If all the forces of internal interaction, if I add them, then what will I get? Let's understand this. Summation of all the internal interaction forces, right, plus summation of all the external forces upon total mass m. Now try to understand this thing, students. By this summation, what I am going to get? Let's try to understand. See, this summation will be 0. Now you will ask me, sir, why this summation will be 0? There is a pretty easy reason. If I talk about particle number 1, it is being interacted with other particles, right? Simultaneously, the same amount of force, if there is F here, minus F is here. That means if 1 is being pulled by 2 with a force F, 2 is also being pulled by 1 with a force minus F. Similarly, if this is F dash, then third particle will feel minus F dash. Fourth particle, suppose this is F double dash, so it will experience minus F double dash, right? Can you see that? So if I talk about all these internal interaction forces, their net sum becomes 0 because they are going to cancel each other out in pairs. Are you understanding this thing? They are going to cancel each other out in pairs. That is one very, very, very crucial and important concept, right? So they are going to cancel out each other. Hence, I can say this particular thing will become 0. So whatever is their internal interaction between them among each other, that will cancel out. If I talk about the complete system from particle number 1 to particle number n, all of them, if they are interacting individually with each other, that net force is going to come out to be 0. So when I talk about acceleration of center of mass, this damn thing is going to be 0, and what we will be left with is only the external force summation, which is going to come out to be net external force. So I will say acceleration of center of mass will become net external force upon total mass. Now this is something very, very, very important, right? This is something very important. That means who has the capacity to accelerate center of mass? You will say, sir, only external force has the capacity to accelerate center of mass. Apart from that, internal forces are not capable of doing. Let me make it very clear. For example, I have one electron and one proton, right? So what's going to happen? The center of mass of electron and proton will definitely lie towards proton, right? Like this, closer to the proton. If I leave them, what will happen? They will attract each other. They will attract each other due to their own mutual electrostatic attraction. They will attract each other and they will start moving towards each other. Can you see that? If center of mass is here, this is proton, this is electron, and if I leave them, what's going to happen? They are going to attract each other. The only force of interaction between them will be their own electrostatic attraction. They are going to move towards the center of mass like this, right? While they are moving, while they are applying forces on each other, the net internal force is already 0 and there is no external force on the system. So what will happen? The center of acceleration of the center of mass will become 0. That means if the center of mass was at rest, its velocity was at rest, it will remain at rest and they will come like this and collide at the center of mass. Are you understanding this thing? That means the internal force that the electron was applying on the proton and the force proton was applying on the electron, that doesn't has any capacity to change the velocity or accelerate the center of mass, change the velocity of center of mass or accelerate the center of mass, right? I'm so sorry, actually I'm suffering from little bit cold. Anyways, now let's take the next slide. Okay, so finally we can come to this conclusion that only and only net external force has the capacity to accelerate center of mass. This is something very, very, very interesting. That means other particles might move, other particles in the system might move here and there, but if there is no external force in the system, the center of mass will not change its velocity. Now let's understand what is the meaning of not changing velocity. Try to understand this, students. If acceleration of, okay, now if in a system there is no external force, suppose in a system if there is no external force, then I can pretty much confidently say that acceleration of center of mass will be 0 and obviously this will be 0, which means this will be constant because derivative of a constant is always 0. Okay. And what is this? This is momentum of the system upon total mass. This is going to remain constant. So finally, we can say that momentum of the system will be a constant. That means if there is no external force, then this thing is true. Do you get it? So if there is no external force in the system, then its center of mass will not be accelerated velocity of center of mass will be constant, and hence the momentum of the system will be constant, and hence the momentum will be conserved. Okay. So, the momentum of the system will be conserved or constant. Now, what do you mean by constant? Like means the momentum before some event and the momentum after some event, it is going to be same. That means I can say that initial momentum of the system, initial momentum of the system will be equal to final momentum of the system. Do you understand this, students? This is simple, simple, simple. Okay. So, this is also known as conservation of linear momentum. Conservation of linear momentum. This is where we derive it. This is how we derive it. If there is no external force in the system, then its acceleration of center of mass will be 0, and hence velocity of center of mass will be constant, and hence momentum of the system will remain constant, and hence initial momentum of the system before certain event, and it will be equal to final momentum of the system after that event. Okay. This is all about conservation of linear momentum. I hope you understand this thing. Now, I am just going to discuss two more points in which velocity of center of mass is being constant, then what does it mean? So, there are two things. If it is constant, either it can be a 0 and constant, or it can be something non-zero and constant. Okay. So, this can either be, let me change the color, either it can be 0, still a constant, that means center of mass is at rest, and if there is no external force, it will continue to be at rest. Second case, velocity of center of mass is a non-zero constant, like 5 meter per second, 4 meter per second. Okay, is when velocity of center of mass is a non-zero constant value. Okay, that means center of mass will move with non-zero velocity and will continue to do so. Okay, that means what I am trying to convey here is, what message I am trying to convey here is that velocity of center of mass, if it is 0, in the beginning and there is no external force acting, then what will happen? Even though the internal system changes, even though the particles moves internally, but in the absence of any external force, the center of mass will remain at rest if it was at rest before. Now, coming to the second point, if the center of mass was moving with a constant velocity, right? If the center of mass was moving with a constant velocity and there is no external force, and still somehow the particles interact individually, internally, they change their positions, they accelerate or whatever happens, but the center of mass will continue to move with the same velocity, it will not change, right? Now, you will say, sir, please give some examples. Okay, brilliant. I am going to give you a few examples on this and then we will move ahead with the lecture. So, I hope now it is very much clear to all of you that how we can conserve the linear momentum of a system in the absence of any external force. Okay. So, now conservation of linear momentum will give you two concepts in your head whenever you understand or whenever you read it anywhere. Conservation of linear momentum, number one, means that the total momentum of the system is constant before as well as after a certain event, right. Second thing, that the velocity of center of mass is constant. Third thing, acceleration of center of mass is 0. So, conservation of linear momentum comprises of these three things actually now. Are you understanding? It comprises of these three things. Okay, brilliant, brilliant, brilliant. Now, let us take some example. You will say, sir, what are the examples to it? Very simple, very, very simple example I am going to take. Suppose there is a gun. I'm just taking a very simplest of the examples. Okay, so this is a simple gun. Right now the bullet is inside the gun, right? And the gun and the bullet as a complete system is at rest right now. Okay, is at rest. Now, if I hold the gun in my hand and I try to fire it, what will happen? The gun will recoil with a certain speed. Now, why it will happen? Why the gun is going to recoil? See, it's very simple concept. You will say, sir, as the bullet is fired, right? What will happen? The bullet will come out with velocity v1, right? The bullet will come out with a velocity v1, and let's say its mass is m1 and the mass of the gun is m2, and it will go back with a velocity v2. Now, why it will happen? The thing is, velocity of center of mass was 0 initially. Since there is no external force, whatever force is applied on this bullet, same force is applied on the gun. So, net internal force is 0, there is no external force, so net force on the system is 0, and hence acceleration of center of mass is also 0, right? Now, acceleration of center of mass is 0, velocity of center of mass is 0, that means center of mass will remain at its own place, it will not move. That means about center of mass, these two things are going to move. So, what will happen? If it moves forward, then it will start moving backward such that the net momentum remains conserved. How? You will say, sir, what is the initial momentum of the system before firing? You will say that 0 because both the gun and the bullet were not moving. Now, what is the final momentum of the system after firing? You will say, sir, m1 v1 plus m2 v2, right? Now, what will happen? Since there is no external force, so I will say initial momentum of the system will be equal to final momentum of the system, right? So, we will say 0 is equals to m1 v1 plus m2 v2. From here we can say v2 is minus m1 v1 upon m2. Okay. Recoil speed of gun. I hope you understand this point. This is very simple. So, this is how you are going to figure out what is the recoil speed of the gun. So, this is all a concept related to conservation of linear momentum. Are you getting it? Okay. So, let us take another example. Okay. Now, let me take another example. Suppose let's take an example where the center of mass is at rest, okay, and so, let's take an example of a bomb, right? It's a very simple thing. Let's take an example of a bomb. There's a bomb whose mass is given m. It is at rest initially, that means the center of mass is at rest, right? Now, this bomb actually explodes into 3 components in such a way that one component whose mass is m by 3 flies off in this direction, right, with a velocity v, right. Another part whose mass is also m by 3 falls off in this direction, okay, and this angle is 60 degrees. Now, one more part is remaining, another part is remaining, another m by 3 is remaining. So, what will be the velocity of this particular fraction of the bomb? Okay. So, the question is, find the velocity of last m/3 after explosion. Now this is a very simple concept. Now how we will do it? Let's try to figure out. See, when the bomb was at rest, the center of mass was at rest and there was no external force, and when the bomb exploded, okay, when the bomb exploded, then it was divided into 3 equal fragments, m/3, m/3 and m/3, 3 equal fragments, out of which the two fragments went with velocity, with the same velocities or with the same speeds v and v at an angle 60 degrees with each other. Now they ask us to find out in which direction with what speed m/3, that is the third equal fragment, will go. Are you understanding this concept? Okay. Now what we will say? We will say again, since there is no external force in the system, so the net momentum of the system will remain conserved, and you will say, sir, initial momentum of the system will be equal to final momentum of the system. Okay. Now what is initial momentum of the system? You will say, sir, it is 0, right? It is 0. Now what is final momentum of the system? Tell me, how will you write it? Now the particles are moving in 2-dimensional space, so you will write it like this. You will break these velocities into 2 components, okay, and you will say, where it is, yes, you will say, sir, one component will be this, another will be this, another will be this, another will be this, right? Okay. So this angle will be 30 degrees. So you will say, sir, m/3 into v cos 30 degrees, okay, minus I cap, and I will multiply 2 with it. Now why I am doing this? Because both are having this component, cos component, in the same direction. Both these 2 fragments are having the cos component in the same direction. That is why I am saying 2 times m/3 v cos 30 degrees minus I cap. Now you can clearly see that these 2 components will get cancelled out, so no need to even add them. After this I can say plus m/3 times velocity vector v3, let's say. Okay. So now if you equate them, you will find out the answer comes out to be vector v3 is 2 cos 30 degrees into v into I cap. That will become, cos 30 is what, root 3 by 2. So it will be root 3 v times I cap. I hope it is understood to all of you students. Okay. So this is how we can figure out the velocity of the third fragment of the bomb. Clear? So these are certain concepts about the motion of the center of mass. Okay, these are certain concepts about the conservation of linear momentum. There are many more concepts, and we will make another video in which I will be describing how we can apply this particular concept in other questions, okay, like man and boat question, in which a man is trying to reach the other end of the boat, and how much does the boat displace. These questions we will be covering in the coming videos. Till then, try to understand this much concept about conservation of linear momentum, and thank you for watching. Please subscribe to our channel and try to learn as much as possible. Thank you so much.